Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache ODE. Apache ODE, short for Orchestration Director Engine, is an open-source implementation of the WS-BPEL standard. It allows developers to define, deploy, and execute complex business processes by orchestrating web services. Whether you're new to orchestration or looking to understand how Apache ODE fits into modern enterprise architectures, this video will guide you through everything you need to know. So what exactly is Apache ODE? At its core, Apache ODE is a BPEL engine. It's designed to execute business processes defined in the web service's business process execution language. BPEL allows developers to define workflows by orchestrating interactions between different web services. Apache ODE provides a runtime environment to execute these workflows, making it a critical component in service-oriented architectures. Why would you choose Apache ODE over other orchestration tools? First, it's based on the WS-BPEL standard, which ensures interoperability with other tools and platforms. It supports long-running processes, fault tolerance, and compensation mechanisms, essential for enterprise-grade applications. Additionally, being built on Java, it integrates seamlessly with popular frameworks like Apache Axis 2 and Tomcat. Apache ODE is composed of several core components that work together to execute business processes. The process engine is the heart of ODE, responsible for interpreting and executing BPEL processes. The deployment layer handles the deployment of process definitions. The messaging system manages communication between services, and integration APIs allow ODE to connect with external systems and databases. The architecture of Apache ODE is designed for scalability and reliability. It starts with BPEL process definitions, which are deployed to the engine. The runtime execution engine then interprets these definitions and manages the execution lifecycle. The web service integration layer handles communication with external services, and a database is used to persist process state and variables. To fully appreciate Apache ODE, it's important to understand BPEL. BPEL, or Business Process Execution Language, is an XML-based language used to define business processes. It supports constructs like sequences, parallel flows, and scopes for error handling. BPEL processes define how web services should interact with each other to accomplish a business task. Let's look at a simple BPEL process example. Imagine a customer places an order. The BPEL process would first receive the order details, then invoke a payment service to charge the customer. Next, it would update the inventory system to reflect the sale, and finally, send a confirmation email to the customer. Each of these steps is defined as a service invocation in the BPEL document. Installing Apache ODE is straightforward. First, download the latest version from the Apache website. You'll need Java 8 or higher installed on your system. ODE can be deployed on application servers like Apache Tomcat or integrated with Axis 2. After deployment, you'll need to configure a database connection for storing process states and variables. Once Apache ODE is running, you can deploy your first BPEL process. Package your BPEL file along with any WSDL definitions into a zip archive. Use ODE's deployment API to upload and activate the process. You can monitor the deployment status through the management console and test it using sample SOAP requests. Executing a BPEL process in Apache ODE begins with sending a SOAP message to the engine. The engine then interprets the process definition and executes each activity in sequence. It handles service invocations, manages variables, and ensures proper error handling. Once all activities are completed, the engine returns the final response to the caller. Apache ODE manages process states throughout their lifecycle. A process can be active, meaning it's currently executing, suspended, where it's paused waiting for input, or completed when all activities are finished. ODE supports long-running processes by persisting their state in a database, allowing them to survive system restarts. Manual intervention is also possible for debugging or correcting issues. Error handling is a critical aspect of BPEL processes. Apache ODE provides fault handlers to catch and manage exceptions. Compensation handlers allow you to undo previous actions in case of errors, ensuring data consistency. Retry mechanisms can be configured for transient failures, and comprehensive logging helps in monitoring and debugging process execution. In BPEL, scopes are used to define boundaries for execution and error handling. Variables within a scope store process data and can be of simple or complex types. Scopes allow you to isolate parts of a process, making it easier to manage errors and data flow. Each scope can have its own fault and compensation handlers, providing fine-grained control over process execution. BPEL supports parallel execution through flow activities. These allow multiple activities to run simultaneously, improving performance for complex processes. Synchronization points can be defined to wait for all parallel branches to complete. Independent execution paths reduce bottlenecks, and join conditions ensure that the process proceeds only when specific criteria are met. Apache ODE excels at integrating with web services. It can invoke external SOAP services defined by WS-BPEL documents. While primarily designed for SOAP, it can also work with REST-TFL APIs through adapters. Asynchronous communication patterns are supported, allowing processes to continue while waiting for responses from long-running services. Integrating with databases is essential for many business processes. Apache ODE supports JDBC-based data access, allowing you to execute SQL queries directly from BPEL processes. It handles transaction management to ensure data consistency and persists process variables in the database for long-running workflows. Apache ODE provides a web-based management console for monitoring and managing deployed processes. You can track process instances, view execution logs, and monitor performance metrics. The console also allows you to deploy new processes, undeploy existing ones, and manage process versions. Security is paramount in enterprise environments. Apache ODE supports WS security standards for encrypting and signing messages. Authentication and authorization mechanisms ensure that only authorized users can deploy or execute processes. Secure communication channels protect data in transit, and access control policies can be applied to individual processes. To ensure optimal performance, Apache ODE benefits from several tuning strategies. Database performance can be improved through indexing and query optimization. Caching frequently accessed data reduces latency. Asynchronous processing allows the engine to handle multiple requests concurrently, and resource pooling minimizes overhead from creating new connections. Let's explore a real-world use case: order processing in an e-commerce system. When a customer places an order, the BPEL process in Apache ODE handles payment processing by invoking a payment gateway. It then updates the inventory system and sends a shipping notification to the logistics provider. Each step is orchestrated seamlessly, ensuring a smooth customer experience. Another common use case is a loan approval system in banking. When a customer submits a loan application, the BPEL process performs a credit check by invoking external verification services. It then conducts a risk assessment based on the customer's profile and financial history. Finally, the process makes an approval or rejection decision, notifying the customer accordingly. How does Apache ODE compare with other orchestration tools? Compared to commercial solutions like Oracle BPEL, Apache ODE is open source and highly customizable. While it may lack some enterprise features, its strong community support and integration capabilities make it a viable choice for many organizations. The decision often comes down to specific requirements and budget considerations. To get the most out of Apache ODE, follow these best practices. Design processes in a modular way to improve reusability and maintainability. Implement robust error handling to ensure reliability. Monitor performance regularly to identify bottlenecks. And use version control systems to manage changes to your BPEL processes over time. When working with Apache ODE, there are several common pitfalls to avoid. Overcomplicating process logic can make it hard to maintain. Ignoring error handling leads to fragile systems. Poor performance tuning results in slow execution, and a lack of testing can introduce bugs into production. Awareness and proactive measures can help you avoid these issues. Apache ODE can be extended to meet specific requirements. You can develop custom activities to perform unique tasks not covered by standard BPEL constructs. Its plugin architecture allows for seamless integration with external systems. Scripting support enables dynamic logic execution, and APIs are available for building custom management tools. The Apache ODE community is a valuable resource for learning and troubleshooting. Mailing lists provide a platform for discussions with other users and developers. Comprehensive documentation and tutorials are available on the Apache website. GitHub repositories contain source code and examples, and community forums offer peer support for common issues. While Apache ODE remains a powerful tool, it's worth noting that it's in maintenance mode. Development is community-driven, with fewer updates compared to active projects. Organizations using ODE may consider migrating to modern orchestration tools for new projects, though it continues to provide solid support for legacy systems. If you're considering migrating from Apache ODE, start by assessing your current processes and identifying dependencies. Choose a target platform that meets your future needs, such as Camunda or AWS step functions. Plan the migration in phases and thoroughly test each step to ensure functionality is preserved and performance is maintained. To deepen your understanding of Apache ODE, explore the official documentation on the Apache website. Online courses and video tutorials offer structured learning paths. Sample projects on GitHub provide hands-on experience, and community forums and blogs are great for staying updated with tips and best practices from experienced users. Let's walk through setting up a demo environment. Start by downloading Apache ODE and installing it on your local machine. Deploy a sample BPEL process using the management console. Use SOAP UI to send test requests and monitor the execution logs to see how the process behaves in real time. When working with Apache ODE, you may encounter common issues like deployment failures, process execution errors, database connectivity problems, or performance bottlenecks. Check the logs for detailed error messages, verify your configuration files, and ensure all dependencies are correctly set up. Community forums can also provide solutions for known issues. Testing is crucial for ensuring the reliability of BPEL processes. Use unit testing with mock services to validate individual activities. Perform integration testing to verify interactions with real services. Load testing helps identify performance bottlenecks, and automated test suites can be integrated into your CI/CD pipeline for continuous validation. Version control is essential for managing BPEL processes in a team environment. Use tools like Git to track changes to your process definitions. This allows multiple developers to collaborate effectively, roll back to previous versions if needed, and maintain an audit trail of all modifications made to the processes. Effective logging and debugging are key to maintaining Apache ODE processes. Enable detailed logging to capture execution traces and error messages. Use debugging tools provided by the management console to step through process execution. Monitor process instances in real time and analyze execution traces to identify and resolve issues quickly. As your workload grows, you may need to scale Apache ODE. Horizontal scaling can be achieved by deploying multiple instances behind a load balancer. Optimize your database for better performance and implement caching mechanisms to reduce latency. These strategies ensure that your orchestration engine can handle increased demand efficiently. Let's recap the key concepts we've covered. Apache ODE is a powerful engine for executing BPEL processes, enabling orchestration of web services. It supports robust error handling, integrates seamlessly with databases and external systems, and provides tools for monitoring and management. Understanding these fundamentals is crucial for leveraging Apache ODE effectively. Thank you for watching this comprehensive tutorial on Apache ODE. If you found this video helpful, please like and subscribe for more tutorials on enterprise integration and orchestration technologies. Don't forget to leave a comment with any questions or topics you'd like us to cover next. Sharing this video with your network helps us reach more learners like you. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.